In this video here, we're going to extend our knowledge of trigonometry by looking at non-right angle triangles. Okay, so we looked at our rules for right angle triangles. So Pythagoras' theorem and SOHCAHTOA, they were quite key to using them for right angle triangles. Now we're going to look at the case, right, well, for every other triangle, when we don't have a right angle ultimately in there, how do we solve them? And it's not too bad. We've two nice concise rules we can use that can help us ultimately solve a triangle. And when we say we want to solve a triangle, we're always trying to find all the angles inside a triangle, and remember, all those must add up to 180 degrees. 180 degrees. And we also want to find all the sides, all the lengths of the triangle, and you'll see the sides and the angles, they kind of work in opposites. So if you have the angle A, it's going to be opposite the side A. The angle B is going to be opposite the side B. The side C is going to be opposite the angle C, and we can use capital letters to denote the angles, or and ultimately small letters, lowercase letters, to show the sides. Okay, so this is a non-right angle triangle, so it means none of the angles are ultimately equal 90 degrees. They make it very close to 90 degrees, but they don't equal 90 degrees. So that's always our first question, is this triangle a right angle triangle, or is it a non-right angle triangle? When it's a non-right angle triangle, we can use one of our first rules, which is called the sine rule. Okay. Now the sine rule states a couple of things, alright? Ultimately it states that the side A divided by the sine of the angle A will equal the side B divided by the sine of the angle B, which ultimately equals the side C, the length of C, divided by the sine of the angle C. Now that equation can look a little bit odd at the start, because ultimately you've got two equal signs in there. But what it's really trying to say is that we can work this in pairs. So we can just use this portion of the equation, we could just use this portion of the equation, or indeed we could just take this portion and link it with this portion. So really what we do is we get ultimately three equations from this. Ultimately, that A divided by sine A will equal B divided by sine B, or ultimately A divided by sine A will equal C divided by sine C, or finally B divided by sine of B equals C divided by the sine of C. So ultimately that full representation there is really just an expression of three different equations that could be used. Now that may look confusing, but if we just think about it like this here, what we're saying is the sine rule works for any triangle when you take them in pairs with ultimately their side and their angle. Okay, so that would be a pair, and you let that equal to another pair in this format, where the length of the side is being divided by the sine of the angle, because it's the sine rule. Okay, so remember, you've got to work ultimately in pairs, and you can take any pair you want. So you can take the A pair and the B pair, or the A pair and the C pair, or the B pair and the C pair, and ultimately they will always equal in that ratio for any triangle. So it's a brilliant formula. But just be sure you're always working with opposite pairs. So you see the angle A is opposite the side A, so them two are a pair, and you can use them in the format of the sine rule with the C pair, so the angle C opposite side C, or indeed the B pair. Okay, so very powerful rule, and ultimately we can use this rule if we want to find an angle or a side, when we know the other two you know, when that's the only unknown in the equation. So let's just take a quick example. Let's say, and we will put this in a different color. So just a quick example. Say C equals 10 meters. We'll say B equals 8 meters. And we know big B equals 78 degrees. Now it doesn't matter with the sine rule if you're in radians or degrees, just make sure your calculator is corresponding to that. So ultimately what we're saying here for this is we're saying that B, so the side B, 8 divided by the sine of 78 degrees will equal C, which we said was 10 divided by the sine of C. So now there's only one unknown in that equation, so we can rearrange it. So ultimately we will get sine C equals 10 multiplied by the sine 78 degrees divided by 8. And then if we just move over here, then that will tell us, and we can find C will equal ultimately the inverse sine of all that when we calculate that out. Minus 78 all divided by 8, and you will get your answer for C. So that's how you use the sine rule. It's, you know, it looks like it may be a complicated formula, but it's ultimately 3 separate formulas. Just when you're taking them in pairs, you can use any pair, the A pair, the B pair, or the C pair. And you want to use a pair ultimately where you know one full setup. So here we know the B pair setup, the side and the angle, and then that you know one part of the other pair. So ultimately you're left with one unknown in your equation. You can manipulate that and you can get the angle or the side that you're looking for. So that is our sine rule. In the next video we will look at the cosine rule.